All right, now let's try doing integrals of some more interesting functions so that we're finding a volume rather than just an area. So first we'll integrate this function 2 over 1 plus x squared plus y squared squared dy dx, and this from -1 to 1 in the x variable, and then 1 minus x squared and root -1 minus x squared at the bottom. So we're going to approach this by rewriting it as a polar integral. So something dr d theta. Well, from these bounds, we can see that we're integrating over the unit disk. So our bounds for r and for theta will be r goes from 0 to 1, and theta goes from 0 to 2 pi. Then remember that, so if we rewrite, let's do the inside first. So we have 2 over x squared plus y squared. So this is r squared. So 1 plus r squared squared. And then remember that dy dx is r dr d theta. So we have, maybe I shouldn't have written these to begin with. So now we've adjusted the bounds, we've adjusted the inner thing. Now the dy dx becomes r dr d theta. Okay, so to then integrate this, we'll substitute u equals 1 plus r squared. So du is 2r dr. So our integral becomes 0 to 2 pi. All right, 0 to 2 pi integral. So the bounds for u will be 1 plus 0 squared is 1, 1 plus 1 squared is 2, and then that's du over u squared d theta. Okay. Now, integral of du squared over u squared, or sorry, integral of du over u squared is -1 over u. We evaluate that at 2 and at 1, and then d theta. So this is -1/2 minus 1. So this is just 1/2. So this is 1/2 integral 0 2 pi of d theta. And so pi is this integral, is the value of this integral. And again, that would have been much harder to find if we had stayed in Cartesian coordinates rather than converting to polar. Next, let's try integral from -1 to 1 and from -√1 minus y squared to √1 minus y squared of ln x squared plus y squared plus 1 dx dy. Well, again, we can see from these bounds that we're integrating over the unit disk. So our integral becomes, we'll put theta first, so 0 to 2 pi, or theta on the outside rather. So integrating with respect to r first. So integral 0 to 2 pi, 0 to 1. Ln, this becomes ln of r squared plus 1. And then recall dx dy, so this becomes r ln r plus 1 dr d theta. Now again, we'll substitute u is r squared plus 1. So du is 2r dr. This becomes integral 0 to 2 pi integral from 1 to 2 again of and then 1/2 of ln u du and then d theta. So the integral of ln we recall is, so this will be 1/2 integral 0 to pi u ln of u minus u at 2 and at 1. So that, and then that de-integrated with respect to theta. So that will be 1/2 integral 0 to pi 2 ln 2 is ln of 4. You could also have just left it as 2 ln 2 minus 2, and then ln of 1 is 0, and then minus 1, so plus 1. And then that's a constant. And we integrate with respect to d theta. So this becomes pi times ln of 4 minus 1 is the value of this integral.